Matrix multiplication also has a bunch of properties that are similar to multiplication with plain real numbers. And this chart from the book tells us some of it. Um, Matrix multiplication is associative, which means if you've got three things and you want to multiply them together, it doesn't matter if you multiply the first two and then multiply that times the last, or if you multiply the second two together and then multiply the first one times that. Matrix multiplication also distributes across addition, and it also works for when addition or when the multiplication is done after the addition here. So let's look at verifying the associative property. Um, this example here, we've got three matrices. First, let's make sure that we can actually multiply A times B times C. If you look at the sizes, this is a 2 by 2. Let's see, B, I have to think about this one for a second. What we've got there is 2 rows and 3 columns, so 2 by 3. Then we've got 3 rows by 1 column. So is it possible to multiply these guys out? Yes, because these two numbers are the same, and then these two numbers are the same. So we can multiply this out, and our result is going to be a 2 by 1. And the sort of intermediate results, if we multiply these two together, we'd get a 2 by 3. And if we multiply these two together, that would give us a 2 by 1. So let's multiply these out. ABC and ABC. This is just sort of a demonstration to show that if we do the multiplication in either order, it'll work. So AB. Let's use octave to do this. All right, I've already got A and B in there. A is this, B is this. So if I do A times B, it gives me this matrix. See, 16, 6, 31. Minus 1, minus 3, minus 7. So if I take that and multiply it by C, I get this. 292 and negative 52. Now if I do this in the opposite order, if I take A and I multiply that by BC, so let's work out BC over here. B times C. Now from up here, B times C is supposed to be a 2 by 1. Yeah, 5280. See, the bottom one there is definitely going to be negative 52. And let's just use octave to multiply this out. B times C, A multiplied on the front. I have to give it that star. 292. So sure enough, whether you multiply AB first times C or multiply BC first and then multiply the A on the front, you get the same thing. Now this actually brings up kind of an interesting thing. A square matrix is a matrix where you have the same number of rows and columns. So like in this example up here, A was a square matrix, but the other two weren't. Those are the only matrices that you can raise to a power. And if I come over here to octave, like my matrix A, I can take A and square it if I want to, or raise it to the 10th power. But if I do the same thing with matrix B, if I try to square it, notice it gives me an error. It says for powers, only square matrix arguments are permitted, and one argument must be a scalar. So yeah, it's saying if I try to do if I do A to the B, it's going to give me a similar error. Can't do that. But you can raise A to a power. And one other thing I want to mention is if you have a square matrix, raising it to, say, the 5th power, that's the same thing as multiplying it out 5 times. And the associative property says that we could divide this up however we want. I'm not sure how Octave does this. My guess is it probably goes left to right in general. But it doesn't matter. If we force it to do certain things first, it's going to give us the same answer. All right. What's this next example? Verifying the distributive property. We've got those same 3 matrices, and let's just do this on Octave as well. If I take A times, oh wait, no, those aren't the same 3 matrices. A is the same. B is different. 1, 2, 1, -1, 0, 3. And C now is 2, 1, 1, 3, 5, 0. All right, so if I take A and I multiply that times B plus C, it gives me an error because, again, I forgot my star, asterisk. So A times B plus C gives us that. But if we do AB times AC, or plus AC, it gives us the exact same thing. This that shouldn't be there. So I'm not going to write this out. We can just see it on Octave that this works.